Good morning. This is Jim Chastain, EasyPower Support Engineering. It's time for the EasyPower Refresher session. This is a special edition. We're pleased to announce the eagerly awaited EasyPower software application for tablets. It's called OnSite, and it's available now for download from the Windows App Store. You know, when we first envisioned this product, many of our customers were complaining about the inefficiency of the data collection and modeling phase of the Arc Flash study. So the primary focus for the initial release of the product had three critical objectives: create a simple-to-use, flexible data collection tool, automate the process of constructing a one-line diagram, and then facilitate the easy mapping of the data that was collected to EasyPower. At the heart of all the product decisions here at EasyPower in terms of new features and new tool development is the basis that we're devoted to increasing the productivity of our customers' capabilities and skills. OnSite's a mobile application that enables you to collect data and model your electrical power system components. So there are several ways for you to work with the information, and you can choose the method that works best for you. With this mobile app, you can record important power system data using the simple-to-use electronic forms or spreadsheets. You can create one-lines by connecting the dots as you perform the data collection in the field. You take pictures or import them, link them to your projects, draw sketches, make notes, and link those to specific elements in the system. And then you can review your project data to ensure that all the required information is complete while you're still in the field and have a chance to do something about it. Then, upon completion of the collection process, you can export the collected data for analysis in the EasyPower tool suite itself. And the big point that I like to make here is the collected data in the original format stays with the EasyPower file. So at that point, you have a direct connection to the person that's doing the analysis. Now, in the previous two refresher sessions on planning for data collection, we emphasized having a plan of attack as you were beginning your Arc Flash hazard assessment. The same is true for utilizing the EasyPower OnSite tools as well. And what we're going to show here is just a brief overview of the capabilities, how to use the tool in a typical data collection situation, and then frankly invite everyone to try it out and let us know what you think. Now, the existing workflow for data collection is very hard copy intensive. It involves having to track templates, handwritten notes, frequently large bundles of one-line diagrams, and then you're going to be generating new notes, new pictures, new logs, and in some spaces this is all tough to keep up with. Once the information's been collected, then you have to manually transcribe this on the forms, and then someone has to go into One-Line Designer or another EasyPower tool and construct the one line again while you enter the data that was collected. OnSite replaces all of this effort, and as we enter the data into a tablet, it can be exported from the tablet into EasyPower directly with all of the data intact. The significance is the data collector does not have to be an EasyPower expert because they're two different worlds. The tablet world utilizes and leverages the capabilities of a mobile platform, and at the point that the file is exported, then the EasyPower authorities can take over from there. So utilizing mobile tablet not only increases productivity, it also elevates the value of the data collection process when additional information can be collected for other goals. We'll touch on that briefly as I get into the demonstration. So let me just say briefly, this tool is a unique first of its kind tool that's not just a template. It does not replace any other EasyPower product. It quite literally is a tablet application that helps the collection process without forcing the person doing the collection to be an expert in any part of the analytical side of EasyPower. Beta testing shows that there is a reduction of 10 to 20% just in the data collection itself, but actually more than a 50% savings when you look at the time required for modeling the one-line diagram in EasyPower. And that's where significant savings will be recognized. So now, at a bare minimum, there's a certain amount of data that's required for short circuit and arc flash, and those forms are built into the on-site defaults. But by adding a few more equipment details, which can be done in notes and can be done in the templates by modifying the templates themselves, we can actually expand the capabilities and the value added of doing the data collection by incorporating this additional information in terms of asset organization, tracking, maintenance files, and the like. So what you're going to see as I get into this case study is that we're going to start a project. We're going to utilize the connect the dot capabilities in the one line, and then for panels and MCCs, we have spreadsheets that we can log data into straight from a panel schedule or a panel itself, and leverage the capabilities of what the tablet can do for us in terms of doing hand drawings or taking notes with or without a keyboard. So primarily I'm going to work with the basic templates in OnSite, and I will focus on primarily data collection for arc flash. But as we go through this, please consider the alternatives if the collection process maybe is constrained by plant shutdowns. It might be wise to collect data at some other time or in different parts of the plant until you have access to energized equipment that may not normally be accessible. So my assignment will be now to go out and collect data for a new project that we've contracted for. My boss, as they provided the quote, took a picture of the utility closet, and I can utilize this to kind of anticipate what my initial goal will be. And let's start here as we open up the on-site application. So let's try it out. So as I launch the application on my tablet, and I'm using a laptop that has a tablet mode, so I can kind of incorporate the webinar session, it presents me with the ability to generate a new project. So we do that. We're going to give it a new name. We'll call it Jim's First. And the basic project screen shows me the ability to change settings, do a review export, create a one-line, create a spreadsheet, take pictures, and then generate sketches. So let's start with the one-line. Actually, before I do that, let's get into my settings, and I'm going to use a default setup as far as the templates. One of the things I want to see are the properties that I can modify. I know going into this that my cables will incorporate essentially a system that's grounded through the conduits, and I need to include my neutral cables, which are carried through the cabling system. So I see those as all part of my general cable setup. I also want to go look into the buses because I will be using an MCC, I'll be using a panel. And part of the panel description will be a discussion about the neutral cable connections. So with these changes, I can incorporate what the selection list is for each of the settings. So as far as the neutral bus, I want to include its capabilities both in terms of number of conductors and whether or not there's insulation. Then in the case of the spreadsheets, again in my panel categories, I want to include in the conductor category all the information about the neutral. And so I can see right here I don't have in the basic template any of the data on neutral conductors. So we're going to put in the number of neutral conductors. We're going to add the size of the neutral conductors and whether it's insulated or not, and then might as well put in the material. So with just that, I've modified the template that's being used for this particular project. So now I'm going to start a one-line diagram, and I know based upon the information that was passed to me, we're going to call this Jim's first, just to keep everything on the same keel. I know the information that was passed to me that I have to deal with the utility information. So I'm going to bring a utility onto my one-line diagram. And I know there's a transformer sitting out there by the curb. Now, as I have an element highlighted on the one line, you'll notice I can just click on the little plus sign above and to the right of the new element. And as I do that, it automatically connects the dots for me. I'm going to come back and select the utility, knowing in advance that I had to get this information from the utility company. I went ahead and took a picture of the data that they sent us. And as I open this up, you can see that my utility company has politely told me that I'm working on the main building. The current, or on a short circuit, phase to phase, voltage fault current is 2290, phase to neutral is 2001, and they've given me an X over R of 3.38. Excellent. So now I'm going to go back to my properties. Again, I'm in the utility. We know the voltage is coming in at 4,160 volts. Don't know what to describe the service type. I believe it's commercial. I don't know exact maximum capacity. The frequency is 60 cycles. And my short circuit phase current is 2290. My X over R, 3.38. And my short circuit line to ground was 2001. And you'll notice they didn't give us an X sub 0, R sub 0 ratio. I did, this is a Pacific Northwest Electric company I'm working with. And at that point, I've got the information recorded for posterity and to be passed along with a file. I've taken a picture of the utility, the transformer. So let's bring that into the file. And here's a picture of the nameplate. Let's make sure it has all the data that I want before I leave the site. All right, so I see the name of the company that manufactured it. I see my kVA rating. I see it works with a 65-degree rise. It's 60 cycles. It's a class OA. It's an oil-filled. It's rated at 480 volts primary, 4,800 volts primary, 480 volts secondary. And I got a serial number. Don't normally need that, but I'm going to record it because we're doing additional asset tracking for the customer. My impedance ratio is 3.37, and I've got a data manufacturing here that I want to make sure I keep track of. All right, I think we're cool with that. Let's go ahead and enter that information on the property sheet. Okay, so now I've entered each of those values into the template. You'll notice as we make these entries, there's already a preset list of default values that I can choose from, and as we come across new values that weren't necessarily part of the default settings, I can type those in, and it becomes the tool literally smart enough to learn what I'm adding and gives me that part of my presentation list in the future entries. Okay, so this brings us to the next element, which will be a point of connection. Actually, I want to put the point of connection in before the utility so that I can record the voltage. So I'm going to highlight the transformer. We're going to disconnect it. I'm going to put a bus in on top of it, so connect to the utility symbol, add a bus. We're going to call this utility point of connection. And record the voltage. And that's where I want to put my transformer. You notice there's a little, as I come in close proximity, it gives me the little blue dot to say that it recognizes the need to connect it. Now the next thing on my list is going to be the cable that goes to the building from the transformer. So now as I highlight the transformer, I can click on the little add the cable conductor, and I'm ready to go inside the building. Now the characteristics of my cable, I measured it to be 85 feet long. The manufacturer's on the label says it's Cero wire. Number of conductors per phase is single. Copper material, single core. Insulation is THWN. As I type it in, it recognizes that it's already on the list. I'm working with 250 kcmil. There already exists, and we're not worried about the insulation jacket. The rated voltage is 600. We do have a conduit, and it's steel, single conduit, 3 inches in diameter, and there's not a ground involved in the system other than the conduit. I have a single neutral. Neutral size is the same as my conductor size. Insulation material is copper, and it is insulated. And so with that, we have my cable identified and characterized. Now I recognize from looking at the utility closet, the first thing that my cable is where my cable is terminated is on a fused disconnect switch. So we're going to add a fuse. We're going to add a switch. Again, these are in alphabetical order, so I can kind of just scroll back and forth as I add them. And I'm taking a picture of each of these. So let's open up my fuse and go in and bring in my picture. And here's a picture of the fuse itself. And this gives me the ability to kind of make sure I have all the data connected or collected. So let's highlight what we're looking for. First of all, it's a class K5 fuse. Catalog number is FRS 400. It's Fusetron, which I recognize to be a brand name from Bussmann. And down here at the bottom, I can see that it's a 600 volt, 200,000 amp rated fuse. And it's 400 amps is what we're working with. So we should be able to enter all of that data. So I've entered each of those values into my properties for the fuse. I'm ready to go to the fuse switch. Open up the disconnect and take a picture of the whole fuse, of the whole switch itself. And I notice there's something a little bit odd about the way that this has all been set up. So I need to make sure I convey that information to my person doing the EasyPower analysis. But as I see this, my connections come in from the utility at the top, and my loads are all connected here at the bottom. And rather than just the one cable I was expecting to go to the main distribution panel, I see at least two others here. And so in effect, what the original construction team did was utilize this particular termination point as a bus. And I want to recognize that as I connect the dots in the tablet. So let's save this and then carry these through to my note. So now I go to the Notes tab here at the top for the switch, and I want to record exactly what my observations are. So here I've made a note now that the terminations at the bottom of the fuses in the switch panel are effectively a bus, and right off the bat I can see the large cable goes to the MDP, which is my main distribution panel. That's what I'm going to work on first, and ultimately I need to understand where these other two cables terminations go. So and when I get back to my details, the properties for the switch, I see that it's a square D. So I'm recording that square D is the manufacturer. The model I recognize as a safety switch. A catalog is referred to as a heavy-duty safety switch, type HU, 3 phases, 600 volts. I rated it for 400 amps, 60 cycles. I don't see the short circuit current rating on it, so I'll leave a note to that effect and have the engineer work on that when he does the import. So the last thing on this particular section, and I guess to kind of take this one step further, I'm going to go ahead and let's go ahead and include the picture I took of the whole closet. So I'm going to go into the properties here for the switch. Let's go ahead and bring in the overall picture and talk about it real briefly. And again, make myself some notes, both for future reference and for the purpose of talking about what I'm about to do. All right, so we're looking at the picture as I look at the project. I'm seeing the main current come in through the main power, come in from the utility, go back to my MDP, which is this panel on the right. I see that it has loads that go out to the reduced voltage or step-down transformer. There's a square D and an Eaton transformer, both of which go to panels. So for the purpose of this demonstration, I'm going to map out how to do an outboarded transformer, and then I have some number of motors, presumably that go to these starters, and I'll see on the schedule that I have other motor loads. So this kind of gives me a clue on how I want to take my one-line diagram. So now as I go back to the my one line, I'm going to go ahead and show the dots or the connections here. The next thing that comes below the switch is the cable that goes to the MDP. And it turns out it's the same type of cable that it was used here. It's just much shorter. So I'm going to select this cable 1, copy it, select cable 2, paste it, and then change the length from 85 feet to the 8 feet that we have here in the closet. And we're good to go there. At this point, I'm going to stop now and go to my spreadsheet for the main distribution panel. So we open up the spreadsheet. This is going to be a panel. We're going to call it the MDP, staying with the nomenclature they're using. And I see by opening up the door, and you'll see the picture in just a second, that this is a 42 circuit system. So we're going to call this MDP. Nominal voltage is 480 volts. And OnSite takes me to a wizard that kind of characterizes what my loads are going to be. And I see, as a general rule of thumb, these are all 3-phase loads. Everything's going to be has a feeder circuit. We're using molded case circuit breakers. Most everything has a cable and a motor load. So that's where we're going to set up our basic panel structure. And now it's up to me just now to record what each of these loads is. So while we're here, let's go take a picture of it and talk a little bit about the plan of attack. So here's what the top of it looks like. All right, so I've brought in pictures of the whole panel and the main, and then a little bit about how the systems looks. So as I take a wide shot or a wider view of this, here's what the MDP main distribution panel looks like. I've got a large breaker at the top, then my 42 circuit breaker panel, and then some kind of funky standalone breaker here that I'm going to cover a little bit later. And so the first thing I want to look at is the characteristics of this main control breaker. So the incoming, if I kind of zoom in on this, I can see this is a Cutler Hammer KD35. I see down at the bottom, KD35 tells me it's a 3-phase, but it's got a 400 amp trip unit in it. And interestingly enough, as I look at these diodes, they're all set up for 10. So I have the maximum delay for trip sensitivity. And then I have additional information here that I can record. So let's go ahead and reflect that in my properties for my main. So I'm going into the main distribution panel. We see that's a Cutler Hammer. And I'm going to go back into the spreadsheet of it. So what we're looking at now is the incoming main. It's a 3-phase breaker. It's Cutler Hammer. So now I've entered the data for the incoming protective device, multi-case circuit breaker, Cutler Hammer, catalog number, the trip settings. I want to make a point here now. I left the conductor, the cable that comes into this, as part of my one-line diagram. So at this point, I need to connect the dots. So the way I do that is I do have a cable, but it's an existing cable on the one line. And so as I click existing, it says, sure enough, you have one hanging out here. Is this the right one? And the answer is yes. And so now it gives me the connections and the details from the one-line diagram for that particular cable. Now I'm going to do the same technique now as I go back and look at my my loads and the panel schedule breakers itself. So now I'm looking at the panel schedule, the breakers. I can see the first 3 loads on the left side all go to this Eaton transformer that's routed off to 208 volt single phase loads in the lower building of SP2. And then on the other side, on the right side, I can see that my first load is actually this offload pump. And on this side I have a 60 amp breaker, and on this side I have a 100 amp breaker. So I'm going to handle those differently in my spreadsheet. This one I'm going to outboard the transformer, and then this one I'll have it loaded both cable and load inside the spreadsheet itself. So let's see how that's done. So first on my one line, I'm going to put a cable that's not terminated because this will be coming out of the MDP. Here's my Eaton transformer, and then the linking cable that then runs to the other building to a panel that we're going to call SP2. It's going to be a panel. Let's just leave it as a bus for now. It's going to be a SP2 in the lower building. Nominal voltage here will be 208 volts. The cable that's running from I can tell by the connections inside my breaker panel. It's a 10-foot cable, same manufacturer, single conductor. It is copper, it's single core. Now it's not THWN, it's THHN. And it too is running through a conduit. It's a number 8 AWG. It's rated for 600 volts. It's running through a steel conduit. There's a single conduit, and it's a 2-inch diameter. There's not a ground except for the conduit itself. We're running the same size neutral. It's copper, and it's insulated. Now, I see the same conductor goes from the transformer to the cable, to the lower building. So I'm going to take a copy of this conductor, copy it, and then put it down into this location. Except this one I've noted and measured, instead of being 10 feet, is actually 145 feet. So we should be good there. Okay, that brings us to the transformer. Again, I've taken a picture of the nameplate, so let's attach it at this point. And make sure all the information is available so I can record it into my spreadsheet, my properties list. So what I see here is a 480 volt to 208, works with a 150 degree rise. It's a 45 kVA. It is a built in 2004. Serial number 4.37 ratio. What else am I missing? Nice thing about it is with this capability, even if I miss something, it's still available and I just have to refer to it as I step back. All right, I'm ready to take this information to my properties sheet for this transformer. So now that I've completed the transformer properties, I'm ready to kind of recap where we stand here. So if you recall, we've used a one-line diagram to show what the connection is from utility into my main distribution panel. And then we've also set up this outboard for the Eaton transformer that's going to be going to a single-phase panel in another building. And I need to connect the dots where I have a standalone cable and they just taken back to my panel. So let's go back to the MDP and make sure that we have things set up there. Now we've already connected the main breaker and set up the main breaker in the panel spreadsheet. We're showing that the incoming main is a three-phase multi-case circuit breaker Cutler hammer source with the catalog number KD3500, 3400, 400 amp trip setting, and we've indicated and connected it to the cable that's listed on the one line. One thing I did want to include here in my notes section was that the trip unit for the main conductor, main breaker, has dials all set for 10. So I'm going to enter that as far as my notes. So now in addition to a description here in my notes tab for what the trip units are set at, I have a picture in my media file that's showing what this looks like, and if I want to make some notes on it, I can do that pretty easily with the tablet. And so you can see that we've amplified that and can refer to that as we need to. All right, so this is all recorded in the MDP in the Properties tab. And as we look at this, we'll go to the spreadsheet rather. We see that that's all confirmed in our main incoming. So what we're looking at now is the left side, the first circuit breaker up, is where we're going to outboard our Eaton transformer. So I'm going to call this load the Eaton transformer to single phase panel 2 in the lower building. And we have that set up for the multi-case circuit breaker, and specifically on the details of the manufacturer. We note that this also is a Cutler hammer. The part number, though, in this case is a GHB GFEP. And that's set up for our 60 amp trip. Now this is the cable that's going to be attached to the one-line diagram. So here, rather than talking about the cable, we're going to look for an existing cable, and we'll see that the OnSite connects it for me, and now we'll have the details of that load already set up going to the transformer. So we're happy with that. Now let's go to the right-hand side where we're going to have now the outboard. It's not going to be outboarded in this case. This will be the load of the pump that's going to be powered by the first circuits on the right side. Now if you recall, on the right side we have this offload pump number 2 set up for the first 3 phases there. And so as we go back to our spreadsheet, we will set that up as a load description here. So we want offload pump number 2. Now as we record the breaker specifics, it's a Cutler hammer breaker, GHB, 100 amps. The cable, we can tell by what's coming into the size of the cable, what's coming into the panel. We need to go out and measure the distance to bay 2 where this pump is located. And now that we've measured that out or estimated that out, it's 145 feet. Again, the same Sero wire. Then we record the cable specifics. When we get to the load, this motor is a 100 horsepower motor. We see that the full rated voltage is 460. Don't see the full load amps on the motor nameplate. RPM is 1800, frequency 60 hertz, and I didn't get the serial number. All right, so at this point I have my spreadsheet, at least the first entries on each side, and I'm ready to at least do a check on how my data collection is looking. So let's go and do a review, and what this is going to show me is the equipment that's containing any invalid data, or if I have missing or hanging CHAD, and I see that I have, it's showing me a cable to the lower building. So this is essentially the cable that was set up when I set the transformer entry line on the spreadsheet, but then I overrode it when I connected it to my one-line diagram. So in this case, I'm going to look at, see where it's located, and you can see it's only in the data on the database. It's not really included in the one-line diagram. So I'm going to eliminate this, and I think we're good to go. So I'm just going to select this and delete it, and everybody's going to be happy. Now I'm ready to go back and export this and see how everything looks in EasyPower. Before I go there, I note that on my one-line diagram, I have these little wavy signs at the end of each cable. That means that it is connected, and so I don't have anything floating as I was first concerned. And as a data collector, my job is done. Let me jump back into my PowerPoint. So what we've done is just effectively the first 2 breakers of our control panel and an outboarded load. And I'll kind of jump back into it and show you what the full system looks like after we've entered all the spreadsheet information. The app is available currently at the Windows App Store. You need to set up a Microsoft account. If you don't have one, download the app. Then you would utilize the App Store to get upgrades, to be able to register the license. The demo license itself is restricted to 1 install for a single user. It's free for 30 days. And at the point you're ready to sign up for the subscription, you need to contact EasyPower Sales for a full license. recommended system, we suggest that the operating system, in fact, the operating system needs to be Windows 10. You need to have an Intel processor, Atom 7 or equivalent. You need to have a 2 gig of RAM, 64 gig of mass storage. Works best with a resolution on a display of 1920 by 1280, and especially if you're going to be taking pictures with it, a good quality camera with optics that can probably deal with 8 megapixels. I need to have a USB port, and that's pretty much enough horsepower to make the system run. Now, on this particular installation, I also have EasyPower 9.8, so I'm going to take a second and jump in to show you how that looks like when we export from OnSite and then pick it up in EasyPower. So when I've finished filling out the spreadsheet, it turned out I had 2 outboarded transformers. So on the left I have my utility coming in and connection to my MDP, and then on the right I have the 2 outboarded transformers that I wanted to connect into my control panel. And then let's look at the schedule for the control panel. What we see here is the left side where all of my, effectively all my loads are detailed out. And as I look through all the data that we've collected, this is the cable data, and then we get down to specific motors where we have or loads in case of lighting or heaters. Same with the right side. The schedule is effectively all completed, and we have a number of spares that are indicated there. All right, so as I've completed this, I want to export my file. I have the ability to export a specific panel either as a bus or as a panel. Let me kind of show you what both looks like. So we're going to export it as a bus. The tool asks me to identify where the panel is located and then where we're going to save the file. So we will do that and then pick that file up. It's going to be a zip file that includes all the pictures and the notes and the on-site data. So now let's go into EasyPower and show you how that. Now again, these features are only available in 9.8 or later. And what we're going to do, I've already opened this up in the past, so I'm going to open up Jim's plant and show what the tool looks like. To bring this in, I went to Import an On-Site Project, and as we pull it in, it draws the one-line diagram, and in this case I've shown all of the loads as they would be as standalone buses. And you can see that the one line is in pretty good shape. Looks like we're missing some data on the second transformer. But the thing I wanted to point out, as we look at the specific data box for each of these elements, there's a special feature now, this extra panel included in the EasyPower presentation that shows me, in this case, the picture, and if I have the details of the notes that were collected. So if there's any question about what I need to do to complete the analysis, all that information is available to me that my data collector provided. So I can quite frankly just cut and paste or copy and paste as I want to take this information into EasyPower. All right, appreciate the time spent today. I didn't mean to kind of draw this out as much as I did. There are online tutorials as well as instructions on how to download and launch the application available through the Microsoft App Store. Search on EasyPower OnSite. As I indicated, the download is free, and when you're ready to talk about the subscription, please contact sales@easypower.com. There are more details on EasyPower, and be more than happy to hear back from you to see what your thoughts are as far as the capabilities of the tool. This, frankly, is just the introduction of this particular product, and it will continue to grow in capabilities through the rest of this year. Did want to highlight that we have a number of pre-recorded refresher sessions, including all of these topics that are listed here, and they are all available on the EasyPower website with previously recorded webinars. Likewise, we have training scheduled for the balance of this year. Later next month, I believe, is in Secaucus, New Jersey. Middle of the year in July is going to be a session in Portland, Oregon. And then more towards September, we were going to have a training session in Vancouver, BC. Also look forward to harmonics and dynamic stability presented here in Portland later in the year. So that should be pretty exciting stuff. Appreciate everyone attending, and we'd love to hear what you think about our new tools. Have a good day.